Okay, so section 2.6 is on rational functions. Rational functions are like those reciprocal functions that we looked at way back when we first started talking about parent functions. They may have horizontal asymptotes, have vertical asymptotes, and they may have something called a slant asymptote. And we're going to talk about that here in just a moment. So a rational function is a function of the form f of x equals n of x over d of x, where n of x is your numerator polynomial and d of x is your denominator polynomial. Of course, the domain of this function is all x's such that the denominator is not equal to 0. Sorry, this is of the form, and I should just say f of x equals, my fault. Mistyped it. And n of x and d of x can't have common factors, so you want to simplify them first. Polynomial over a polynomial. We have to watch our domain to make sure we're not doing anything illegal like dividing by 0. So your vertical asymptotes occur where that domain is equal to 0. In this particular example, we've got f of x equals 2x minus 5 over x minus 2. So we have a vertical asymptote where? Bless you. Where does it look like this asymptote is? 2. Not just 2, though. If you just say 2, I'm going to count that wrong on your quizzes and tests coming up. It's a line called x equals 2. Okay? There's a vertical line there that it can't touch. A hammer line. Now, next one, horizontal asymptote. In this case, your horizontal asymptote is, it's possible that it can actually cross that, provided that as it approaches infinity, it's just approaching that line. But this one happens to have a horizontal asymptote here at y equals 2. Good. Okay. And the reason it's y equals 2 is nothing to do with this denominator being 2, but it has to do with these leading coefficients here. And we'll talk about that in just a second. And the powers of the polynomials as well, or of the numerator and denominator. Okay? So, rules of asymptotes. Yes? Common factors, correct. So what we have to look for is to see if I can factor it all out, and if I have an x minus 2 in the numerator and the denominator both, then I'll want to cancel that. Okay? But we can't cancel our x's, we can't cancel our 5 and 2 or anything like that because they're not identical. They have to be factors in order to cancel them out. Okay? So the rules of asymptotes says that the graph of an f of x, or of a function, has a horizontal asymptote or no horizontal asymptotes depending on the degree of the numerator and the denominator. If the degree of the numerator is less than the degree of the denominator, then your x-axis will be your horizontal asymptote. The highest power in the numerator is less than the highest power in the denominator, then y equals 0 is your horizontal asymptote. Okay. If the degrees are the same as they were in that first example, then it's the ratio of the leading coefficients. So we had something like 2x minus 5 over x minus 1. Because the powers are the same, The leading coefficients are what we look at, and we take 2 over 1, and that ends up being the value of the horizontal asymptote, where y equals 2. Okay. Lastly, if the degree of the numerator is bigger than the degree of the denominator, then there isn't a horizontal asymptote. Instead, you'll have a slant. Okay. And our graph will look something like this. We have a vertical going on here. And it may look something like this. Okay. We're going to talk about that some more. Give you some time to write if you're writing. Remember, when you're taking notes, you're abbreviating these notes for yourself. So a lot of times I will say ASYMP for asymptote, DEG for degree. Okay, everybody ready? So, plan of attack. First, you want to simplify f if possible. Factor the numerator, factor the denominator, see if there's anything in common. If so, cancel. Then you're going to sketch your vertical and your horizontal asymptotes, or your slant asymptote, as the case may be. Then you'll find the x and the y intercepts if that's possible. So those are usually easy numbers to figure out. And then you're going to plot at least 2 points per branch. Make a t-chart, x-y coordinates. Finally, you'll connect your points with a smooth curve, coming ever so close to those asymptotes, but not necessarily crossing them. Everybody good? Not quite? A couple more seconds. All right. So we are asked to graph f of x equals x squared over the quantity x squared minus 4. First step is always to simplify if possible. Okay? 2x squared will not cancel or will not factor. X squared minus 4 is an x plus 2 and an x minus 2. We don't have identical factors in the numerator and denominator, so we can't cancel anything. Okay? So where is our vertical asymptote going to be? 2 and we'll actually have 2 of them, won't we? So what can't x become? Can't be 0 in the denominator, right? 2 makes that happen. and also -2. So is it okay if I do these by halves so that we have a little more space here? Okay, so this will be a half, this will be 1, 1.5, 2. So I've got a vertical asymptote here at x equals 2. And then another one here at x equals -2. Okay. Horizontal asymptote. Well, what do we notice about the powers? They're equal, so what does that mean? We find our coefficients of each other, right? 2 over 1, the leading coefficients, will get us our line of y equals 2 in this case. Everybody see that? Okay. So over here at y equals 2, I have a horizontal asymptote. So what's our domain? X can't be what? 2 or -2, right? All real numbers such that x is not equal to plus or minus 2 would be one way of saying it. Or -infinity up to -2, but not including -2. -2 up to 2, but not including 2. And 2 up to infinity would be the interval notation for it. Now we've got to put a little t-chart together. So if I'm going to pick the easiest one first. Let's put 0, 0 in here. Make sense? When x is 0, sorry, not 0, 0, but plug it, x equals 0, and 0 over -4 is going to be 0, right? Okay, so 0. So we know we have a point right here. Okay. Everybody okay with me plugging in 1? 1 over 1 squared, or sorry, 1 times 2 is 2 over 1 squared minus 4. When I'm at 1, I'm at -2/3. What's going to happen at -1? The same thing, -2/3. So when I'm 1 over, I am 2/3 of the way up. And when I'm at -1, sorry, I'm going to be at -2/3, not positive 2/3. Use the full eraser. Learning this eraser. All right, so -2/3. I'm at 1 over, I'm 2/3 down. So half, almost 1. -1, almost 2/3 down. Okay. Can we see kind of what's going on here? It's kind of looks like a parabola, doesn't it? Okay. So this isn't necessarily going to be, yeah, kind of will kind of be the peak. So it's going to look something like that. But then we have to figure out what's happening over here on the right. So if we plug in a 3, 3 squared is 9 times 2 is 18. 3 squared is 9 minus 4 is 5. No, 18 minus 4 is 14. So 18/14 is 9/7, so 1 and 2/7. When we were doing 3. 3 squared is 9. Sorry, I don't know where I got 14. 9 minus 4 is 5, so 18/5. All right, so 18/5 is 3 and 3/5. Okay, so when we're over here at 3, we're going to be at 3 and 3/5. 3 over 1, 2, 3, and 3/5. Okay, and then what's going to happen as we're at 4? 4 squared, 16 times 2 is 32. And 4 squared is 16 minus 4 is 12. 32/12 is what? 16 halves, or 16/6? 8 over 3. So when we're over here at 4, we're at 8/3, which is 2 and 2/3. So it's going like this. Okay? Then on the other side, when we plug in a -3, we're going to get those same values, aren't we? Because there's no way that the sign is going to change. So at -3, 2, going to be here, and then we're going to be up. It's going to look like this. Kind of messy, huh? That's what asymptotes do to your equation. That's what happens when we divide by fraction, or divide by polynomials. Okay, so next one. First step. Oh, oh, sorry, I should have gone back to the range. My fault. So range, what don't we get to become? Yeah, we can't be between here at 2 and really above 0, can we? So everything above 2 and everything below 0. So negative infinity to 0 and 2 open bracket to infinity. Y is greater than equal to, it can't be equal to, greater than 2, or y is less than 0. Absolutely. That's kind of this, all real numbers such that y is bigger than 0 and or less than -2. Yep, yep, you could. They're all the same. Okay, so next one, sorry about that. First step, simplify. Okay, so I'm going to give you the assignment. We'll come back and look at the slant ones. So do what you can with these, okay? If you see that your power in the denominator or numerator is bigger than the power in the denominator, skip them for now. 9 through 15 odd, 17, 26, 27, 29, 33, 57, and 60. No, well, do what you can, and we'll pick up on the other couple things.